acceleration. As we must have learned in our early classes, that acceleration is defined as the rate of change of velocity. Now we are going to consider the rate of change of velocity. The rate of change of velocity is what we define as acceleration. And already in our previous slide, we have also described that velocity as a vector quantity. So we can as well consider a particle that is moving in the x-axis and is having a velocity at a time function of, let us consider a situation whereby we have a particle moving along the direction of plus x-axis with a velocity of v at an instant of time, which we call instant acceleration or instantaneous acceleration, as already discussed under velocity. So here we have a particle moving towards the positive x-axis with a velocity of v at a time interval of t, changes course from t to t plus dt, and because of that, the velocity is also going to change from v to v plus dv. So we say the measure of change in velocity with respect to time at an instant of this time is what we call instantaneous acceleration. So acceleration as a function of time can be given as, we represent this numerically in physics as acceleration being a vector quantity is given as the rate of change in velocity. That is instantaneous acceleration is also the rate of change of velocity, which is also a vector quantity divided by the change in time. So this is the way we relate instantaneous acceleration to physics. So we can also say, as already discussed in our previous chapter, that we can also say acceleration is given as a slope or the derivative, anyhow you want to put it, is acceptable, the slope or derivative of velocity time length. So students should bear that in mind and should be very, very careful when dealing with acceleration. Now, similarly, or in due course, we can as well say, from what we have studied under the velocity time graph, that when we differentiate displacement time graph, we are going to get velocity. And when we differentiate velocity time graph, we are going to get acceleration. Now, in this case, we can also say, when we differentiate displacement time, we have velocity, differentiate velocity time graph, you have the acceleration. Similarly, we can also say when we integrate acceleration time graph, we are going to have velocity, and when we integrate velocity time graph, we are going to have displacement. So we always keep it in mind that differentiation is the reverse. Of integration. So this should be kept in mind because of numericals. So similarly, we can also express acceleration in two different forms. So we can keep it in mind because of examples. Now, the first case we say acceleration, which is the slope of velocity time graph, is written as dv by dt. Now, which we can also write from what I've explained here, that if we differentiate displacement time graph, we have velocity. If we differentiate velocity time graph, we have acceleration. So if I go by this, differentiating displacement time graph 2 times, I'm going to have acceleration. So it depends on the way the examiner is bringing the question or the parameters that are given in question that will decide which of the formula you are going to use. So expressing acceleration can be as a function of velocity time graph, and I can also write it as a function of double differentiation, which we call the square x over the t square. That is, if I differentiate displacement time graph twice, I'm going to have acceleration. Now, similarly, acceleration in physics can also be written in terms of We have acceleration, already discussed as a slope or the rate of change. Instantaneous acceleration as the rate of change of velocity with respect to time. Can also be written as when we multiply this equation by the x divided by the x. Everybody know when we say the x means the displacement. Now the x by the x is 1, so 1 multiplied by the v by the t is going to give us what we call acceleration at angle. But in physics and mathematics, complexity can set up. So students need to keep this in mind, because if we go by the x by the t, the x by the t, we have already discussed that the x by the t, that is the rate of change of displacement time graph, is going to give us velocity. I hope students understand this. I'm considering the x by the t. So now we have the v by the x, which we call I said the v by the x, which we call the x by the t. Then we have the v by the x, which we can write as a rate of change of the v by the x. So this case, we can also have acceleration in terms of velocity, and it can be in terms of displacement. So students should be careful about these two, because when we talk about numericals and calculation, we can actually acceleration in different forms. So by and large, what I'm trying to say is that acceleration in a nutshell is equals to the instantaneous velocity and the instantaneous velocity, that is velocity at an instant of time, multiply by, this is the case, instantaneous velocity at an instant of time, multiply by the slope of velocity displacement. So this is what I'm saying. So we can always keep that in mind because of what, of some questions. So it depends, like I said, on the nature of the question that will give us which one is going to work for a particular question. So I'm saying, you can see velocity, instantaneous velocity is v, that is the v by the x, that is that. We also have what the v by the t. You can see the x by the t is equals to velocity, already discussed. When you differentiate velocity with displacement with respect to time, you have velocity, and you have the v by the s, which is what we call the slope of velocity and displacement. So in a nutshell, I can say acceleration being a vector quantity is the same thing as the v by the t. You can keep it in mind. In this case, we can call the first formula equation 1. And another way in which we can have it is that acceleration can equals to the second case that I've listed here, which we call v dv by dt. So please always keep these two formula. I'll call this equation 2, depending on the nature of what examiner is given. We use equation 1 if acceleration is given as a function of time. So let that sink. Acceleration as a function of time. This is what we use. And we use the second formula in case if acceleration is given as a function of displacement. Function of displacement. So students should keep that in mind, and to avoid mistake, as a function of displacement. So depending on the nature of the question, it will now tell us which one are we going to use. Now we can also combine the two if acceleration is given in terms of velocity and also in terms of displacement. So it depends. Let us take a simple example to explain this and understand the concept very well. So let me take one example and let's see how far we can solve. Let's say we have, if the particle is displaced, or if a particle displacement is given as, we have our x, which is displacement, is equals to 3t to the power of 3 plus 2t squared plus 5t plus 6. Now the question is, find the acceleration. Find the acceleration at time t equals 2 seconds. Now, to solve this, my dear students, from what I have explained, you have to consider the parameters that is given according to the examiner. And in this case, the examiner actually gave us displacement time. Now we know when we differentiate displacement with respect to time, we have velocity. And when we differentiate velocity with respect to time, we have acceleration. So what I'm saying here is that we are going to differentiate twice, and this is what is sufficient. So in this case, the first thing we do is what? We are going to find the instantaneous velocity, which is the velocity at an instant of time, which we have already discussed at the rate of change of dx by dt. So differentiating dx by dt will give us nothing but 3 times 3 is 9, t, 3 minus 1 is 2, 2 times 2 is 4, 4, then 2 minus 1 is 1. Then when you differentiate this, you're going to have plus 5. Whenever you differentiate its constant, it will be equals to 0. Now, what I have differentiated here, my dear student, is the value of instantaneous velocity. Remember, the examiner asked me to find the acceleration. So if I differentiate velocity with respect to time, once again, it will give me the acceleration. What we have gotten here is the instantaneous velocity. Now I'm going to differentiate again to have what we call acceleration as a function of time will now be equals to the v by dt. And again, differentiating this, I have 2 times 9 18t. Then again, we have when you differentiate this, t will go, you have plus 4. Differentiating a constant is equals to 0. Now here, at t equals to 2, to get the acceleration, I'm going to do a direct substitution. So we can confirm this by saying 18 multiplied by 2 plus 4. So going by this, we have 18 2s are 36, and 36, 18 2s are 36, and I have 36 plus 4, it gives me nothing but what? 40 meters per second squared. I hope students were able to understand, because when we do further examples and numericals, we are going to keep in mind about instantaneous velocity in different cases as a function of time and as a function of displacement. So please let us bear it in mind that whenever we are doing this, we are to be very, very careful and avoid error. So see you guys soon in my future video.